Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken, University of Albany, and Joel Chaiken. Here we are here to help you approach SAT math questions. This is from a non-calculator section, and it is a free response, so you have to give an answer. There's no multiple choice here. So this looks like so you wanted to try it, pause it, welcome back. This is as simple as just take it for what it is. It's just two equations, two unknowns. When you have two unknowns, you need two equations to pin down the answer, to pin out the XY pair. And then you can solve this using two equation, two unknown methods. So probably the most normal way of doing this is first you look and you only care about the X value. So it'd be well worth your while to eliminate the Y. To eliminate the Y, you multiply this equation by 3. And watch what I'm going to do here. I'm going to multiply this equation by -4 because I like to add things. I don't like to subtract things. So that's negative 9x plus 12y is equal to, don't forget this, 60. I always forget this. And then this is negative 24x minus 12y is equal to 60 also. Negative 60. Oh my God, see, I almost made a mistake. Did you see that? Almost made a mistake. You add these equations. This is equal to 0. Well, if that's equal to 0, then you don't even care, right? X is equal to 0. Right? Now you double check to be sure, because you could easily make a mistake. Let's see. This is right. I mean, 3. I'm double checking everything. I'm double checking my distributing things. Okay, 4 times 15. I want to make sure that's right. This is no calculator section. 4 times 15 is 2 times 30, which is 60. There's a negative sign here. Yeah, it looks right. So, just got to be careful.
Okay.
Just got to be careful. Now.
Yeah. Okay.
Yeah.
Well, I could now let me don't erase it.
I'm not going to erase it.
Oh, I have I could point out some cleverness and coincidences that could help you approach the problem so you could get the answer more quickly.
That's what you're here for, Seth.
Okay. Okay. So let's see. Backing up from what Joel accomplished, Joel did this calculation and got x equals 0. So to verify that the solution has x equals 0, what I did was plug in plug x equals 0 into the two equations, and I got 4y equals 20, 3y equals 15. Well, let's see. A quarter of 20 is 5, and a third of 15 is 5. In other words, plug in x equals 0. So all you have to think about is these two, and you can see kind of by coincidence, 4 times 5 equals 20, and 3 times 5 equals 15, which verifies that x is a solution accompanied by x equals 0 is a solution accompanied by y equals 5 is a solution.
Yay me, yay me. I got it right.
Okay, great. Now let me do another approach. Okay, here's the other approach. Let me rewrite the equations. Minus 3x plus 4y equals 20. And see, I'm just rewriting it. If you were doing this on the test, what happened? If you're doing this on the test,
I'm trying to erase my little scribbles.
Don't erase anything. Okay. Don't bother. Okay. I won't write too much. Okay. Just leave it. I wouldn't rewrite them. I would simply do the calculations underneath in the space here. using what's already written. But to explain it, let me rewrite them so that you could see it. You could see my point without interference. So I'll rewrite just 6x plus 3y equals 15. Now, certainly, please think of the idea to eliminate y, and therefore you could solve for x, because the question is to find x. Now, there are a lot of 3's. This equation is divisible by 3.
Right.
So you divide it by 3. So you get 2x plus y. 15 divided by 3 is 5.
Right.
Okay. And now you could multiply this by, let's do it Joel's way. Multiply this equation by -4. And we get what? Minus 8x minus 4y equals minus 20. And then you add, right, these two equations, and we get 0. 20 plus minus 20 equals 0. Plus 4y plus minus 4y equals 0. Minus 3 plus minus 8 is minus 11 multiplied by x. I get minus 11x equals 0, whose solution is x equals 0.
Well, first of all, who cares about the minus 11x? It doesn't matter.
I just added, I just followed my nose in the elimination. Sure, I could have been more clever. And after noticing that the right-hand side was 0, whenever if the left-hand coefficient of x was non-zero, then x would be, certainly. But I didn't think of that. I simply just followed my nose and just did the elimination process. Sure.
Okay, now
if you notice that, more power to you.
Yeah, I noticed that.
Okay.
But I did it. Now, do you notice that I'm going to suggest why do you think your way was faster than mine? Because let me finish.
Okay. My way is fast.
Let me finish. In order to do what you had to do, you had to do two things. You had to divide by 3, and then you had to multiply by -4, right? What I did is I did 2 multiplications. I did a multiply by 3 and a multiply by -4. Each of us had to do 2 things.
Okay.
Right?
Mine is better because the arithmetic involved smaller numbers.
Yeah, but your way.
I don't like the idea of multiplying 20 by 3 or 15 by 4. That's a big multiplication. You'll see that my numbers were none of them were larger than 20.
True.
So I prefer my method because I anticipated that my method would give you smaller numbers to do the arithmetic with.
Okay. Well, first of all, it took a little time for you to realize that. It took a little bit of time for you to realize that. The first thing I noticed, what took me a very quick time to realize, was that to first eliminate y. Second, the second equation is divisible by 3. Dividing it by 3 makes the coefficient of y be 1, which makes it very easy to then eliminate y by multiplying one equation by one constant, right,
and then combining it with the other equation without changing the other equation.
No. I totally understand your point, but maybe just a small argument that division But division is
No, no,
more.
no, no, no. I
No,
just saw 6, 3, 15, all divisible by 3. It's not too hard to divide there.
it's not that hard, but it is a division, and naturally, multiplication comes more natural than division. It just does. It's easier conceptually. It's easier to multiply things than to divide things. It,
Well,
yeah, it
no,
does.
if you no, it may be easier. It may be easier, but if you've studied your math and practiced it, then the other one, the harder thing, is just as quick and maybe more efficient.
Right. Now, but Seth was
Like
asking.
it's easier to learn to dig a hole with a shovel. It's harder to learn to dig a hole with a backhoe.
Right.
But once you've learned to use a backhoe, the backhoe is much better if your hole is big.
Right. Totally agree. Totally agree.
So why not you learn? You want to be a professional builder. Learn to learn to run your backhoe really well.
Right. No, and then now to take your argument to argue on your side, did sort of blow it, but I don't know. I didn't really blow it. But whenever you see equations like these, it's always a good idea to pull out the GCF. Always a good idea to factor equations if you can. So Seth was very observant that whenever you see equations, this is particularly true of polynomials. It's if you see something like this, it really is a good idea to write this as 3x plus y 2x. See, I made a mistake dividing. 2x plus y is equal to 5. It's a good practice to get into that habit.
Yeah.
But so in general, that is a good idea. That is a good idea. When you see equations come up, if you could factor out a number and reduce the equation by factoring using a GCF, then that's a better way to do it.
Yeah.
Okay, great. Well, anyway, but in any case, we haven't come up with a significantly different way of doing it. Oh, we basically did the same thing. Really. I mean, you could also do this through graphical. You could graph these two lines and see where they intersect, which would be stupid. The graphical approach is inappropriate here, and the table approach is also inappropriate. So I guess that's it, right?
Yeah.
Okay, great. So you saw two different ways to approach the same problem, which is good. But it looks like a standard approach. You just two equations, two unknowns. This is called the elimination method. From this point, Seth, you could have used substitution, but that would have been not great, right? Y is equal to 5 minus 2x. You shove that y into here.
I won't do
No,
that.
substitution's not appropriate. It's faster to do elimination. Elimination is the way to go on this.
Okay. Well, it's is a good illustration of a strategic choice of methods.
Yeah. Right.
So you could solve the problem quickly,
right,
which will bank you time to work on problems where you need more time.
Right. Yeah. Okay. I guess we're done, right?
Looks good.
That's good. Okay, great. Like us, dislike us, give us comments. You may email us your SAT math questions at gmail.com.